Hydraulic design is the process of calculating the capacity of the watercourse crossing structure to accommodate stream flow and fish passage. It is also required to select an appropriate type of crossing and its configuration. Hydraulic design is necessary to make sure that the crossing functions as intended, to pass water, fish, and avoid a road washout. Hydraulic designs are normally completed by a hydraulic or hydrotechnical engineer for two important reasons. First, the calculations are specialized and often complex. Software is available to do many of the calculations, but a professional will be in a better position to understand if the calculated numbers are reasonable for the crossing site. The second reason is that there is liability associated with the design, as regulated by the Association of Professional Engineers and Geoscientists of Alberta. In cases such as when a road washes out or there is a failure with the watercourse crossing infrastructure, the owner and engineer may be held accountable. The hydraulic design determines the recommended size of the watercourse crossing structure and the configuration or layout. The hydraulic design process includes choosing a location and configuration for the watercourse crossing, measuring the upstream drainage area from available topographic mapping or surveys, estimating the design flow from the hydrology methods, and calculating the water velocity or speed and depth based on hydraulic analysis methods for a selected structure size. The design process often needs to be refined and repeated to identify an appropriate size because each hydraulic calculation is specific to a selected structure size and type of structure. Design flow refers to the selected capacity of the structure to accommodate peak stream flows. The design flow capacity therefore accounts for variations in seasonal flow, such as possible storm or peak flow conditions up to a selected return period flood event, such as a 1-in-100-year flood. Design flow calculations may also be required to test fish passage requirements during normal flow conditions. The general process for completing the hydraulic design is as follows. Measure the drainage area and channel characteristics upstream of the watercourse crossing based on topographic information. Confirm the fish passage requirements for water velocity and depth related to the potential flow conditions, the length of the structure, and the target fish species life stage. Online tools are available to assist with these calculations. Estimate the design flow for flood peak within a defined time period, for example, a 1-in-100-year flood event, or based on regulatory requirements. There are regional flow monitoring stations and statistical methods to help with this estimation. Survey the watercourse channel at the watercourse crossing to determine the slope, width, substrate, and other features such as bedrock outcrop locations. Ensure that the width measurements include the bankful width and active floodplain. Select a crossing structure type, size, and configuration. Calculate the water depth and velocity of the natural watercourse channel, and for the selected structure style and size. Use hydraulic analysis methods to do these calculations. The process may need to be repeated to find a suitable structure size. Ensure the design of the watercourse crossing structure meets regulatory and fish passage requirements to avoid crossing failure or road washout during high flows, and to allow fish to pass across the life cycle of the structure. General guidelines to keep in mind during the hydraulic design process include: align the structure with the upstream and downstream channel to avoid erosion and debris accumulation at the inlet. Use the natural channel gradient as the basis for sloping the watercourse crossing structure. Avoid design elements that could trap debris and plug the watercourse crossing structure, such as beaver guards. Use regular monitoring and maintenance as the best practice to avoid watercourse blockages at the watercourse crossing due to beavers or debris. There are also some specific considerations when culverts are chosen as the watercourse crossing structure. Minimize the culvert slope to avoid high water velocities. Minimize culvert length to avoid adversely high velocity for long distances, which can make fish passage more difficult. Consider oversizing culverts at cross drains and other ephemeral channels to allow for culvert maintenance. Minimize the risk of buoyancy failure by ensuring the culvert inlet is weighed down by road fill and that the inlet is contoured to a beveled or angled shape. A head wall can also be used to provide support. Buoyancy failure can occur if a long, unsupported culvert inlet is pushed upwards by the pressure in a submerged inlet with low flow inside the structure. Erosion control is a standard aspect of any crossing design. Designers will specify standard erosion control measures plus additional site-specific measures based on the expected water velocity during a design flow flood event. It is important to include erosion and sediment control measures at both the inlet and outlet of the watercourse crossing structure. Design should always include consideration of runoff and erosion from roads. Road drainage should be directed away from the structure to prevent sediment from entering the watercourse. There are numerous hydraulic modeling tools available to help with the calculations. Due to the technical nature of the calculations and the liability associated with the hydraulic design component of watercourse crossings, it is advisable that these calculations are completed by a qualified professional. Once the hydraulic design is complete, the planner can obtain the appropriate watercourse crossing structure from a vendor and continue the watercourse crossing planning and permitting process.